All right, sum and difference formulas for trigonometry, sometimes called sum and difference identities. Why do we need more identities? Well, you already know how to find the sine of 30 degrees and the sine of 45 degrees, but what about something like the sine of 195 degrees? With these new identities, we can find that. So I developed the sine and the cosine trig identities in another video. I suggest that you check that out. But these are the identities. There's a sine sum identity, difference identity, cosine sum, cosine difference, tangent sum, tangent difference. So a couple of things I want to point out here. So for the sine of sum identity of alpha plus beta, you have the sine alpha cosine beta plus cosine alpha sine beta. And then for the difference identity, it's just sine alpha cosine beta minus cosine alpha sine beta. For the cosine alpha plus beta, the sum identity, we have cosine alpha cosine beta minus sine alpha sine beta. And then the difference for the cosine difference identity is that it's a plus sign here. So cosine alpha cosine beta plus sine alpha sine beta. And then you'll see that with your tangent sum identity, we have tangent of alpha plus beta in the numerator, and then 1 minus tangent alpha times tangent beta in the denominator. And for the difference identity, we have a minus sign in the numerator and then a plus sign in the denominator. So one thing that you can do is you can actually condense these identities like so. So notice that we have sine of alpha plus or minus beta. We have sine alpha cosine beta plus or minus cosine alpha sine beta. So if the sign, the SIGN sign, plus minus sign, is on the top, then you follow that same one. So the sine alpha plus beta becomes a sine alpha cosine beta plus cosine alpha sine beta, as you can see up here. Now, for your cosine sum difference identity, we have a plus or minus here, but then we have a minus or plus. So again, if the plus is the sign that you have, then you stick with the top part of it. So that's a minus. So if we go back up here to where they're separated, you can see that when it's a sum, then we do a difference in the identity, and then when it's a minus over here, then it's a plus over here. So that's why we actually use like a minus plus and plus or minus. And then for the tangent, we have the plus or minus for tangent of alpha plus or minus beta. We've got a plus or minus on the top, but we have a minus or plus on the bottom. So we're going to use these identities to find the exact value of the cosine of 175 and also the sine of pi over 12. So what you want to do is you have to figure out from the angles on the unit circle, because we can get easily the sine cosine tangent of those angles. Let's find two angles from the unit circle that add or subtract to be 75. Hopefully you figure out that we can just use 30 and 45. So the cosine is 75 degrees. We're going to break that up into the cosine of 45 degrees plus 30 degrees. So that's our cosine double sum identity, excuse me. So we're going to flip over to the formula, and that's going to be cosine of the first angle, so cosine of 45, times cosine of the second angle, so cosine of 30, minus sine of the first angle, so 45 degrees, and then sine of the second angle, so sine of 30 degrees. The unit circle, cosine of 45 degrees is root 2 over 2. Excuse me, cosine of 45. Cosine of 30 degrees is the square root of 3 over 2 minus square root of 2 over 2, and then sine of 30 is a half. And then we multiply those. So remember, when you're multiplying radicals, you multiply what's underneath. So it's going to be the square root of 6 over 4 minus the square root of 2 over 4. And we can put that all over one denominator, square root of 6 minus the square root of 2 over 4. No, you cannot simplify the root 6 minus root 2. Let's take a look at the next one. So this one, we have to break up pi over 12 into the sum or the difference of two angles from the unit circle. What I would suggest that you do is go to the unit circle and put all of your denominators over 12 to figure out which ones add or subtract to be pi over 12. Well, it turns out that it's going to be pi over 3 minus pi over 4. So again, to prove that, if I put everything over 12, like pi over 3 is 4 pi over 12, and then pi over 4 is 3 pi over 12. So you can see if you subtract those, you're going to get pi over 12. Using the sine difference identity, that's going to be the sine of the first angle, so pi over 3, times cosine of the second angle, pi over 4, minus cosine of the first angle, pi over 3, times the sine of the second angle, pi over 4. And the sine of pi over 3 is the square root of 3 over 2. Cosine of pi over 4 is the square root of 2 over 2. Cosine of pi over 3 is 1/2, and sine of pi over 4 is square root of 2 over 2. So here we're going to have the square root of 6 over 4 minus the square root of 2 over 4. Well, wouldn't you know it, it's actually the exact same answer as our previous problem. And that happens sometimes. All right, next we want to find the exact value of the sine of u plus v. And we're given information about the sine of angle u, that's 4/5, and we're given information about the cosine of angle v is negative 12/13. You're also told that angle u is between 0 and pi over 2, so that's in quadrant 1. And then the angle v is in quadrant 2. So what I'm going to do is I'm going to draw two triangles. So angle u is in quadrant 1. So let's call that angle u right there. And the sine is 4/5, so that's the opposite would be 4, and the hypotenuse would be 5. And we can do the Pythagorean theorem, but this is a Pythagorean triple. The adjacent side would be 3. I'm going to draw another triangle in quadrant 2, and that's going to be angle V down there, that reference angle. And the cosine is negative 12/13, so that's going to be the adjacent side will be negative 12. The hypotenuse would be 13. And then this other leg over here, that's another triple, that's going to be 5. A common mistake here is for students to forget to put the negative in front of the 12 there. But remember, you have to be careful about which quadrant you're in and which sides are going to be positive and which ones are going to be negative. So now that I have that information, let's go back to what they're wanting us to find. We want to find the sine of u plus v. Well, let's use the identity. The sine of u plus v, that is equal to sine of u cosine of v plus cosine of u sine of v. So sine of u, that is going to be, well, that was given to us, that's 4/5. Cosine of v, that was also given to us, negative 12/13. Cosine of u, so looking over here at the triangle where you have the u, the cosine would be 3/5. And then sine of u, looking at our, sine of v, so looking at our v triangle, the sine would be 5/13. And let's just multiply and simplify. That's negative 48 over 65 plus 15 over 65. And so we get negative 33 over 65. Next, we're going to use the identities in order to simplify an expression as follows. We have cosine of theta minus 3 pi over 2. So let's just substitute the identity. That's going to be the cosine of the first angle, theta, times cosine of the second angle, which is 3 pi over 2, plus sine of the first angle, theta, times sine of the second angle, 3 pi over 2. So cosine of theta, well, I don't know what that is because I don't know what theta is, but cosine of 3 pi over 2, well, that's equal to 0. And then sine of theta, well, I don't know theta, but sine of 3 pi over 2, that's equal to negative 1. Well, the 0 times the cosine of theta, that's going to, of course, be 0, and then minus sine of theta. So this entire expression is just negative sine of theta. Next, let's look at the one with the tangent. So go back to your tangent identities and write down the identities. It's going to be cosine of the first angle plus, for number 5, we have a tangent of alpha plus 3 pi. So looking back at the identity, that's going to be tangent of the first angle, which is theta, plus tangent of the second angle, so that's 3 pi, over 1 minus tangent of the first angle times tangent of the second angle, 3 pi. Tangent of theta, of course, I don't know what theta is, so we'll just leave that as tangent theta. Tangent of 3 pi, that's equal to 0. Because remember, 3 pi is going to be the same place as pi, and the coordinates there are negative 1, comma 0, and tangent is sine over cosine, so that would be 0 divided by negative 1, so that's just 0. And then 1 minus tangent of theta, and of course tangent 3 pi again, that's going to be 0. So in the numerator, we have tangent of theta, and in the denominator, I have 1 minus 0, which is 1, so the whole thing is just equal to tangent of theta. All right, this one looks very intimidating, but that's actually kind of fun. I like these. So we have cosine of the sum of the arctangent of 1 and the arc cosine of x, which is totally wild. So what I'm going to do, my approach here is I'm going to introduce some new variables. I'm going to let u equal arctangent of 1. And I'm also going to let v equal the arc cosine of x. So if I go back to the arctangent of 1, if I take a tangent of both sides, then I have the tangent of u is equal to 1. And then with the same thing for the v, I can take a cosine of both sides and say the cosine of v is equal to x. And this helps me to develop our triangles. So like what I did a couple of examples ago. So I'm going to draw a triangle in quadrant 1, and we're going to label that angle there U, and the tangent is 1, so we can just call the opposite and the adjacent side equal to 1, and then you can do the Pythagorean theorem and get the hypotenuse to be 2. You could, of course, if you wanted to, since you know the tangent is 1, you know that the angle has to be 45 degrees. So you could call the opposite and the adjacent side each root 2 over 2 and the hypotenuse 1. You're going to end up with the same result. And then for the V, this one is going to be weird because I have an X in it. So again, we can just draw it in quadrant 1 since they don't tell us that we have any restrictions. So there's angle V down there, and the cosine of angle V is X. So the adjacent side is going to be X, and the hypotenuse is going to be 1. And so I can do the Pythagorean theorem to get that the length of the other leg is going to be the square root of 1 minus X squared. So I set all that up, and now let's go back and make some substitutions. Again, instead of saying arc tangent of 1, remember I said the arc tangent of 1 was equal to U. And instead of arc cosine of X, remember I said the arc cosine of X was equal to V. So let's make those substitutions. So I'm looking at cosine of U plus V. And then it becomes similar to what I did a couple of examples ago. We're going to say then that using the identity, that's going to be cosine of U times cosine of V minus sine of U times sine of V. So cosine of U, so looking at my triangle where I have the U labeled, well, that's going to be 1 over the square root of 2, which of course is root 2 over 2. Cosine of V, well, that was given to us. That's just X, but you can also pull it onto the triangle. Sine of U, that's going to again be 1 over the square root of 2, or root 2 over 2. I'm going to change that in the next step. And sine of V, that is going to be the square root of 1 minus X squared over 1, because the hypotenuse in that triangle is just 1. So let's clean this up a little bit. I'm going to call this the square root of 2 over 2 times X, or X root 2 over 2, minus, this is going to be the square root of 2 over 2 times the square root of 1 minus X squared over 1. So we can take that, we can multiply those radicals there. So that's X root 2 minus the square root of 2 minus 2X squared, all divided by 2. And while it ain't pretty, that is our final answer there. All right, next we're going to do a verifying or a proof of one of these identities. This is actually the cofunction identity. We've talked about this identity a little bit. So I'm going to take the left-hand side of this and I'm going to use the cosine difference identity, which says that we're going to do cosine of the first angle, that's pi over 2, times cosine of the second angle, which is X, and that's a subtraction sign. So remember with cosine it was a minus or plus, so it's going to be plus sine of pi over 2 times sine of X. Okay, that's all on the left-hand side. So cosine of pi over 2, if we go to the unit circle, that's going to be 0, times cosine of X, plus sine of pi over 2 is 1, and then sine of X is just sine of X. Well, the 0 times the cosine, that's going to make the whole thing 0, and then 1 times sine, so we get sine of X is equal to sine of X, so therefore we have proved it. All right, let's do a solving problem now. So I'm going to use the sum identity twice because I have sine of X, the sum identity once and then the difference identity once. So it's going to be kind of long and tedious at the beginning, but you're going to see some things are going to cancel out. Sine of the first angle times cosine of the second angle plus cosine of the first angle, sine of the second angle. All right, that's all of that. Plus, I'm just going to use parentheses to keep my work straight. So that's going to be sine of X times cosine of pi over 4 minus cosine of X sine of pi over 4. Okay, and that's equal to negative 1. Now I put the parentheses there to help organize my work, but the parentheses are not doing anything. So we can see that we have a negative cosine X sine of pi over 4, and over here I have a positive cosine X sine of pi over 4. So those reduce down to 0. And then when we look at the other terms we have remaining, we have sine of X cosine of pi over 4 and another one that's identical. So that means we have 2 of them. So let's go ahead and write down 2 sine X cosine of pi over 4 equals negative 1. Remember, we're trying to solve for X, so we need to isolate the X. Cosine of pi over 4, well, we know what that is, so we'll call that 2 sine of X, and that's the square root of 2 over 2 equals negative 1. Well, the 2's reduced to 1, so now I have the sine of X times the square root of 2 is equal to negative 1. Let's divide both sides by the square root of 2. Sine of X equals negative 1 over the square root of 2, or of course we can call that sine of X equals negative root 2 over 2. And checking back with our instructions, they just want us to solve for x within 1 revolution of the circle. So looking at the unit circle where the sign would be equal to negative root 2 over 2, that's going to be there in quadrant 3 and quadrant 4. So x is 5 pi over 4 and 7 pi over 4.